in this video, we're going to go over, as a group right now, we are going to go over 5 different problems, 5 problems that are related to trigonometry, but this trigonometry specifically is going to be like a reverse. It's called inverse trigonometry. And so here we go. We're going to get started. Everybody go to number 5, please. And we're going to start by drawing a picture that models this information. A ladder that is 30 feet long needs to reach 27 feet up on a building. So can everybody please do this with me? This is 27. We have a ladder that is 30. What should the angle off the vertical be? What should the angle off the vertical be? Now, I personally think that is really poorly written. In fact, I did not create this. This was provided for our team. When I'm thinking of that, I literally am like Googling what is vertical as angle off the verticals. Here's what I'm thinking. Does everybody agree that this is the vertical? So the angle off the vertical would be one of these two, and we know this is 90. So can everybody put a question mark right here? Here's the next thing you're going to write. All earbuds are out. You know this by now, guys. Earbuds are out, cell phones are away. When we need to find an angle measurement, we use what's called an inverse function. So please write that down somewhere off to the side in the margins. When you need to find an angle measurement, you use an inverse function. This is not going to be a hard concept to catch on to if you did well yesterday. If you did well yesterday, because we're just building upon that. So when I look at this angle that I want to be able to determine, I think to myself, what is the 27? What is the 30? Okay, 27 we would call 27 the adjacent, and I'm going to write that down just for those. This would be the hypotenuse, and this would be the opposite. So now I think what major trig function, sine, cosine, tangent, specifically talks about adjacent and hypotenuse. Not everybody has a great memory. So I'm going to come up here and I'm going to write down that acronym. Oscar had, space, a heap, space, of apples. That helps me to remember the sine, the cosine, and the tangent. So now I look up above and I go, okay, I know the adjacent and I know the hypotenuse. They can help me to determine this angle. Adjacent hypotenuse is cosine. So everybody please write this down. The cosine, we don't know the angle. The cosine of this angle equals 27 over 30. Can I have truly a thumbs up or thumbs down based on your understanding right now? It's okay to be thumbs down. Like, that's life. That's life, that's where you are. Okay, next. Like I just said to you a minute ago, whenever we're trying to actually locate the angle, we're going to use the inverse sign. So what we're going to do to both sides, I want you to put a little arrow, and there's a couple different ways we can write this. We can use the word arc, or we can actually write inverse cosine. So some authors like to write arc cosine, and they're going to write arc cosine here. It's just like with algebra. Whatever you do to the left, you do to the right to make sure that the equation is balanced. Now, what does that do? Well, on the left-hand side, arc, cosine, and cosine are going to like cancel each other out. They're going to simplify and disappear. So arc, cosine, and cosine are going to cancel out. That's the reason why I do that. Just like when we're solving, opposite of adding is subtracting, opposite of multiplying is dividing. Well, opposite of cosine is arc cosine. I'm left with this angle. And now you're thinking to yourself, what is the arc cosine of 27 over 30? Well, you don't need to think any further. Come up to your calculator, please. Make sure you are following along with me. The very first thing is I want this answer in terms of degrees. So please go to mode, scroll down, and make sure you are in terms of degrees. Next, how do I plug this in? Well, can everybody see where it says cosine with a little -1? That's another way to write arc cosine. So it's blue. I need to grab that blue. So we're going to hit the blue key and then find the cosine. And it's going to say cosine with that little -1. That means arc cosine or the inverse cosine. Now all I do is I'm plugging in the ratio that I have, and I press enter, and this is going to represent that angle. So this angle is approximately 25.8. So this angle right here is approximately 25.8 degrees. We just use the concept of inverse functions in order to determine an angle. I'm going to say this again. Inverse functions will only be used to determine an angle measurement. Please go down right now to number 7. All right, here we go. Let's look at number 7. So let's see if you did it right. As I walked around, I actually saw one picture that looked like it was correctly modeled based on this. So a man is in a fishing boat that is floating 175 feet from the base of a cliff. You don't have to be pretty with your drawings, but they do need to be accurate. Okay, and we have 175 feet here. This is a man floating in a boat. Gotcha. Now, watch, watch, watch. Please look, please look. What is the angle of depression between the cliff and the boat? This is where people messed up. So, angle of depression, now follow it, from the cliff to the boat. Angle of depression is this drop-down angle. So this drop-down angle we need to know. Now, I got to teach you a trick. Raise your hand if you're like, I had a pretty good geometry teacher. Hands up high. I had a pretty good geometry teacher. Okay. If you currently had or you had a good geometry teacher, here's what you would have learned. You would have learned there's a shortcut here. This is referred to as a transversal. And when you have two parallel lines, which we need in order to describe these angles of elevation or angles of depression, here's what you learn. This angle and this angle will always be the same. They're called opposite interior. So whatever this angle is, it'll be the exact same as this angle right here. This angle of depression will be the exact same as this. Did everybody hear that? Okay, so now that I know that I can figure this out, and then I can be like, hey, it's the same as that. So I'm looking at this angle and I'm like, okay, I can see that 200 is opposite, and I can see that 175 is adjacent. What major trig function, if I look up here, uses that ratio of opposite and adjacent? Tangent. So here we go. Tangent of, I don't know what that angle is opposite over adjacent. When do we use inverse trig? When we're trying to find an angle measurement. So now on both sides, I'm going to do arc, but not arc cosine because I don't have a cosine. I'm going to do arc tan. So arc tangent, and on the left-hand side, it says that a man is in a boat that is floating 175 from the base. So this is 175. And it says the height is 200. So when we do tangent, it is opposite over adjacent.
Oh, so it's not from the top.
What'd you say?
So it's not at the top?
Right, it's not at the top. Yep. But thank you for asking. Arc tan and tan are going to simplify. They're going to, in your mind, like they're going to cancel out. And now we have this angle, and I have the arc tangent of 200 over 175. So grab your calculator, please. Again, we've already checked to make sure that we are in terms of degrees. How do I find that arc tan? I'm going to hit that blue key at the top, and then I'm going to find tangent, which is right here, and I'm going to plug in the ratio in the correct order, 200 divided by 175. So 48.8 approximately. This angle is 48.8. Did they ask for this angle, yes or no? They did not ask for this angle. Turn to your partner. What angle did they ask for? Angle of depression, but I know they're the same. So the angle of depression is also approximately 48.8 degrees. So what does this look like before you were trying one on your own, a separate one? Let's look at this. We've got, and now this may be difficult for some students. Just curious here. I am curious, how many of you have ever had the opportunity to go down a water slide? Hands up high. Water slide? Oh man, those are fun. Those are fun. Okay, so we have a straight water slide. So it's not like one of the curly Q type of things. And it's 175 feet above ground. So everybody do this. This is 175. That's the height of it. This is my slide. That's the diagonal. The diagonal, here's my slide, and it's 200. And I want to know, what is the angle of depression? Okay, this is non-negotiable. You're going to turn to your partner in 5 seconds, and you're going to answer this. Where do you find the angle of depression in this picture? Go. 5. Go. Turn your partner. 4, 3, 2, 1. Here's where you find it. Please watch. You are drawing, if you have not done so, you are drawing a dotted line. That dotted line has to be parallel to this base. And from the top down, please draw an arrow. This is angle of depression. Now, again, if you have a good geometry teacher, you would have learned that this angle, and I'm just going to draw a little circle. This little angle here, this is parallel, and we have this transversal. And so based on the fact that we have alternary angles, I know that whatever this angle will give me is the same. If this is 20 degrees, this is 20. If this is 50, this is 50, and so on. All right, next up, I'm going to call in random people. Care Bear, do you think in order to find this angle, because I know those two are going to be congruent angles, do you think I would use sine, cosine, or tangent, and what is your reasoning? Okay, she did sine because it's opposite of our hypotenuse. It's great reasoning. Here we go. Sine of this angle equals 175 over 200. Mario, how do I know that I'm going to have to use an inverse function to solve this? That little circle called theta. Whenever you want to know the theta, that means the angle measurement. Whenever you want to know the angle, you don't know the angle, we're going to use inverse. Byron, how do I now algebraically write this in order to solve?
Wouldn't you put an arc sine?
Yep, arc sine and arc sine. And then I'm going to write everything else down. Great job. Thank you, Byron. What is my next algebraic step, Lucas?
Press up the accent and the sine.
Yep. And, okay, let's jump here. How do I plug this in? One is we want to make sure we're in degrees. Excuse me. Two is I'm going to take my calculator and I'm going to go second sine. That's how I get what looks like the inverse sine. This is another way of writing arc sine, by the way, and then 175 divided by 200. So approximately 61.0. So if this angle is 61.0 approximately degrees, that means that the angle of depression is also 61.0 degrees. Are you able to correctly draw a picture that models information? That's where a lot of students struggle. So from a 200-foot observation tower on the beach. Okay, so everybody, here we go. Here's my beach. Gosh, I love the ocean. Here's the beach. Here's my tower. So this is my tower, okay? And it's 200 feet tall, and a man sights a whale. Okay, he sights a whale from the tower. So here's the tower. He sights a whale that's having difficulty. So here's the whale. That's right. That's a good whale, Miss Bradley. Thanks. And we want to know, what is this angle of depression? Okay, hold on here. Angle of depression, that means right here is 7 degrees. By the way, since we've talked about this for multiple problems, we have two parallel lines and a transversal. If this is 7 degrees, what is this? 7 degrees. This is not easy stuff. And we want to know how far is the whale from the shoreline. So we want to know this distance right here. I'm going to put an X. This is where it's more difficult than most people think. So I'm going to write tangent of the angle 7 degrees equals 200 over X. And now I'm going to have you turn to your partner. If you chose to use the inverse tool on your calculator, you're wrong. Why is that? Turn to your partner. You have 5 seconds. Go. 5, 4. Turn to your partner. 3, 2, 1. We only use the inverse when we're trying to find an angle measurement. We have 2 of the 3 sides, and we're using an angle, trying to use it to use an angle measurement. I know the angle. It's 7 degrees right here. I'm trying to find a length. And so I'm going to go times x, opposite dividing is multiplying. So right now I have x times the tangent of 7. Now I'm dividing by the tangent of 7 degrees, dividing by the tangent of 7 degrees. Now I'm not using the inverse key, so I'm literally coming up here and taking 200 and dividing it by the tangent of 7. And we can see that this shoreline is approximately 1,628.9 feet. Okay, that is the distance the whale is from the shoreline.